Welcome everyone to today's Design in Dialogue. We have Joris Laarman today. It will be a 45 minutes long conversation followed by 50 minutes Q&A. So please put down your questions in the public chat box and we'll go through them. We are going to record this for archive purpose and we'll put up on Vimeo shortly afterwards. We're also muting everyone just to ensure background clarity. So let's turn to Glenn Adamson.
Thank you, Lucy, and hello to you, Joris. You're looking like you are in idyllic surroundings there under your awning and in front of your Airstream trailer.
I am, yeah. It's a long story. We have bought this terrain near Amsterdam. It's an old military terrain in nature, basically. It's untouched for like 40 years or so. And we bought it with 26 families to start live here and work. And we don't have a living permit yet. So now with all the Corona issues, I cannot really go to the office or to the studio. So it is a perfect place behind the fence where I can sort of work. And we are sort of alone. But it's very beautiful. I can quickly show you. This is actually a sort of old building that we're going to renovate and live. And the view is like a protected, a forest is a large word, but it's it is a lot of trees basically and canals that are supposed to prevent fires and explosions going into the city.
I see. Okay.
It's a monumental area.
So you have some serious room to roam and think then. That's great.
It has been really a privilege to be able to be here. It's if you think about all these people that are in the city, and we have a house in the city ourselves, and we sometimes get crazy. We have 3 kids, so we really need to go out during the day, and this was a good solution.
Excellent. Well, we're really glad you're safe, and so excited to have a chance to talk to you today, of course. I'm going to go ahead and jump right into images because we have so many to show and so much to talk about. But if folks who are listening will, first of all, say hello and just let us know where you're zooming in from. And then also, if you do have any questions for Joris, we'll try to get to those at the end and just put them in the chat box while we're talking and we will try to answer them. So with that, let's plunge into your universe, Joris, which is a dazzlingly beautiful place to be, and also a very compelling place from the point of view of technology and progressive thinking, and I think also the philosophy of design. So I guess the first question I have for you is, if you were to try to explain to somebody how you got into this, how would you do it?
It has been an evolutionary process, I can say. I basically didn't really know what the profession of designer was when I was trying to pick out a college or an academy. I wanted to do something with art, so I went to the design academy in Eindhoven because it just felt right. And then I basically was a pretty confused student until I went studying with Gijs Bakker, the former founder of Droog Design in the Netherlands. And suddenly everything sort of came together. It all made sense. This school and what design was all about and what made it interesting and what not. And that started everything basically. So I graduated with this radiator called Reinventing Functionality. This is an image. Sorry, if you go back to the Google image, I started studying in 1998, and this was exactly the same time when Google launched its first website online. And this changed everything for me. So I didn't even have a computer when I started studying. So basically we are the last the generation that grew up with digital, the digital revolution, you can say. So we are also the last generation that still knows how the world worked before digitalization. I remember when I started studying, we still used the yellow pages to find things, for instance, or look up companies that we could work with, or we used multicolor photocopiers and not a computer or Photoshop or anything. So this dawn of digitalization really was inspiring, and all of a sudden you had this huge amount of information that we could sort of use to create work, and also to find people that were way smarter than ourselves to sort of collaborate with. I think in a sense the internet was like super important for everything that I do. And the other image that you, oh, sorry.
Yeah, I was just going to say it's so interesting to be a bridge generation in that sense, because of course I am as well. We can remember the analog, but we're also so profoundly by the digital.
Yeah. How old are you?
I am 47 this year.
47, okay. Yeah, I turned 40. This is usually when I do a lecture, I show this image. Anita, who is sitting here, who is my wife and co-founder of the lab, she is the first girl I actually started texting with. So I used to write a lot of love letters to girls and stuff. And the strange thing, it says, "Oh, Joris, didn't you hit your head too hard against that lamppost?" Which I did after I kissed her the night before and stuff. And but it's funny how digitalization is like super efficient and things like that, but it also it's kind of sad that we are losing such skills or human factors like writing letters and taking the time to actually write down your thoughts and hopes and dreams and stuff and send that to somebody. And it's kind of analog or an analogy to a lot other things that digitalization and technology is sort of causing. And on the one hand, it's like fascinating and magical and like fantastic opportunities and everything. But on the other hand, we're also losing some really profound and beautiful aspects of life.
So when we come to your first major design project, then the heat wave radiator that you mentioned earlier, do you think that one of the things that Object stands for is introducing a kind of romanticism into this digital era? Is that a fair reading?
I don't know if it if this work already had so much to do with digital, with reacting on the digital world. But it has to do with romanticism, I guess, or expressive form. When I was studying back then, everything was kind of about soberness and conceptual design for sure, but also about getting the essence and trying to be as sober as possible. And I just wanted to create something highly like a concept, but highly aesthetic at the same time. So like a sort of romantic sculpture on the wall with a very strict logic, like form follows function. Basically. So Rococo has a larger surface area, so it would give more heat to the air. So it would just be more efficient if it looked crazy like this. That was kind of the thinking. So this was part of thinking about functionality and sort of creating freedom in quite a sort of a rigid, strict world that is becoming more and more about efficiency, in my opinion. So the climbing wall, for instance, is very much about that too. It's about breaking your routines and showing that not everything is about efficiency. like this is placed in a housing complex where you can take the elevator behind the wall, behind the climbing grips. There's also a staircase behind that one. So you can either take the stairs or the elevator, but you can also climb up this wall to go to the first and the second level. And you know, it's also sort of a metaphor for what's going on with everything becoming more efficient. Like for instance, with Google and Google Maps, and how this sort of we're losing the routes, for instance, that will get you lost, or you know, the areas where you would meet the most people. It would be super funny, right? If Google would sort of create routes that you can walk, where you would be able to meet the most people, for instance, or take a touristic route or so, you know, not going from A to B in the most efficient way. And yeah, that's what this work is about, basically.
I suppose it suggests there's different kinds of optimization, and we're often presented with the idea that the optimal is one thing, but in fact, it of course depends what your value system is and what you're trying to achieve. Like that idea of just getting from the first to the second, or well, how do you want to get there? And it sort of depends, doesn't it? Should depend, shouldn't just be the one option.
Definitely, yeah. I mean, of course, it makes sense to go. It also makes sense to go somewhere efficiently if it's needed or so. But there's much more to life than efficiency, I think. You know, yeah. Well, there's a lot to say about that. This work is also reacting on digitalization, you could say, and how it sort of is dematerializing a lot of things, like value, for instance. And this could be the most invaluable piece of jewelry if you put a lot of debt on it, for instance, or if you put a lot of credit on it, it could be the most valuable piece of jewelry. It's basically a chip, a credit card chip that you can put money on. And it is a way to show your virtual value again, like we used to wear golden jewelry or so. But it's nowadays it's kind of hard to understand value because you can't really touch it, if you know what I mean. It's for me, it's hard to teach my kids about value when they just have a chip, basically, and they put it against some machine, and then you walk out the grocery store with food, for instance. It's kind of strange.
Because it's so abstract.
Yes.
But, you know, there's something there about the role of the designer and putting pressure on these typical distinctions that are made. For example, that the ornamental is not the functional, which the heat wave contests, because of course it's, as you said, its curvature is more functional than a set of straight lines would be. Or the question more broadly of whether the aesthetic is itself purposeful. So that idea of the climbing wall is kind of creating an opportunity for experience that would have a different purpose than just going upstairs. And I feel like that kind of roundaboutness, like not taking the most direct path, and yet the paths that you do take very, very rigorous and thought through, that seems to be a really strong leitmotif and sort of connective tissue throughout your career.
Yeah. Yeah, and then there is experiments. So this is it's also sometimes things are done also in coincidence. So we in this case got together with a scientist working in a laboratory working on biomedical things, and we started talking, and we started talking about living products, for instance. So in this case, I don't know, is this a video or is this a picture?
I think it's just a picture, yeah.
Yeah. So this was about the idea of how we would treat our products if they would actually be alive, if you would treat them like pets, for instance. And this is a living lamp that would illuminate similarly to how fireflies light up. So it is genetically modified cells that were modified with the luciferase gene of a firefly.
Mm.
So it didn't need electricity to light up; it was just bioluminescence. And this is the bioreactor in which it grew. And this was later on filmed lighting up. And this is a product that would basically it makes you think, and it was about imagining a world where basically biological growth could be a way to make things. Biological growth is a super efficient, but not how to say that. It's a great way to make things. Nature has figured it all out.
That maybe prompts a question that I did want to ask you. And while I'm asking you this question, we can look at this incredible rendering of this project that you proposed for the Guggenheim, which perhaps you can explain too. But I also wanted to ask you about the choice to name your studio Joris Laarman Lab, which implies a kind of experimental space rather than necessarily a place of direct production like the word studio might. And I wonder what your thoughts about that decision are, that idea of running a lab.
Yeah, well, this has to do with what we really like to do, and that's experimenting and trying to sort of to push the boundaries and well, think about the future and future products and future ways of working. It's just what we are interested in. And I've worked with industrial companies, for instance, on industrial design, and honestly, it's not our biggest talent, and it was always a bit of a it was not giving us the most joy, I guess. And I think a laboratory is just what we like to do best. I don't know.
Yeah. Can you a little bit about this incredible paper airplane conception?
Yeah. Okay. So this is a concept for the 50th anniversary, I think, of the Guggenheim Museum. It's an old concept, but still very cool. It's also part of the experiment. This is, by the way, motorized paper planes. It would fly as a flock or a swarm in the atrium of the museum. And when the battery would go low, they would fly to a sort of a recharging platform and start joining the flock again. We've worked on this for a year, I think, to figure out how to do this, maybe 2 years even. And we've approached a lot of companies, but this is also part of experimenting, that sometimes you're just too early. That I think right now, looking at the toy industry, for instance, it might make sense to revisit this project, because I think right now we should be able to do something like this. But back then we were a bit too early with the concept. But the concept in general is still, super nice.
It's also a great example of how you take a very complex technology, in this case, this swarming technology and drone technology, and you give it an image that allows it to be incredibly relatable even to a child. And I find that also very interesting that you have a kind of drive to direct communication and also to aesthetics as a way of maybe humanizing the technologies that you're using.
Yeah, I think it's also hard, but I try to sort of mix the alpha and the beta side in myself and in life, to sort of use technology to create something high in emotion, or something poetic, rather than just something that is highly technological, if you know what I mean. And though that's a complex thing to do, to sort of create um, logical beauty, or yeah.
Yeah, it's very nice hearing you talk about this with birdsong behind you, I must say.
Oh, you hear that? Yeah. Oh, that's funny.
But here we see a image, I guess, of the digital in practice, and also a real contrast between different ways of visualizing structure.
Yeah. So this is something I also came across just looking on the internet for interesting new science. And so the image on the right, which is an animation, it shows an algorithm optimizing a certain car part.
Mm.
And I was totally blown away when I saw this. It was part of a larger documentary about mimicking nature. And the amazing thing about it, in my opinion, is that it doesn't just uses an algorithm to sort of optimize a form and reducing its weight, but it also creates a really beautiful organic aesthetics.
Mm.
So it is smart, new aesthetics. And when I looked at this, it was like watching the industrial age sort of transforming into a digital era. And that sort of started me thinking about using this as sort of the sculpting tool of the future, you could say. So it is computer aided or AI, basically a sculpting tool to create functional objects with a logic. So it's not just my own aesthetic opinion. It is a computer basically helping me in ways that I could never think of myself with creating form.
Mm. And that, of course, gets us to the famous bone furniture,
Yeah.
one of your defining early projects.
Yeah. So it's hard to imagine how experimental this was right now, because right now you have this software, you can just buy it online. It's just part of big CAD software companies. But back then we had to really like wait 2 weeks for every iteration that the computer would calculate for each try, basically. And this is in our workshop. This is actually a workshop somewhere in a village near Amsterdam by a company called Grafotech, which helped us to create a ceramic 3D printed mold. And also back then, 3D printing was something new, especially in ceramics. So it was all pioneering, basically. And the problem with this form was that you could not make it in another way. So it's really hard to weld all these parts of aluminium and not seeing the weld marks and stuff. So we wanted to cast it in one piece, and that's why we created the ceramic mold in which it is cast in one piece.
And there we see the object finished and beginning to get polished as well.
Yeah.
Yeah, because there's also a lot of handwork in this after it's formed, correct?
Yeah, I think handwork is a large part of our work, and this is something we think is really important as well. Like I think our world is becoming more and more virtual, and I always think it's super nice to be in a workshop and actually smell and touch wood, and our world is three-dimensional and not inside a computer screen. And also I find myself behind a computer screen more often, which I hate. I really don't like it, but it's also a sort of a necessity to because you can't really ignore digital our digital age, you could say. So I think the combination is nice between handcraft and digital tools. We've evolved as as a species, for hundreds and thousands of years, being in nature and in three-dimensional surroundings and touching and smelling. And it's kind of, we hardly had any time to evolve into these sort of data filters, sitting behind our computer screens. So it is not, I really feel it's not healthy to be only in your head or in two dimensions. I really need to work with my hands, and I think it's an important part of life and work in general.
Do you think that it's also the case that the analog and the digital throw one another into a clarifying perspective? Because I look at an example like this, this piece from the Bone series, and it strikes me that it is like a skeleton and like a tree branch structure, but then it also could be read as being quintessentially digital. And it's like you can occupy these two different vantage points on it, each of which seems more interesting related to the other. You know what I'm saying? Like that moving back and forth from the analog to the digital, both in terms of how you make, in terms of how you look, and they make each other more interesting, rather than contradicting each other.
Yeah. Well, it's like I see it, although you can't really categorize it like that, but it's combining those alpha and beta things like digital technology and human craft. When you combine those, something really interesting happens, I think. And yeah.
It's also interesting in relation to what we were talking about earlier about optimization, because as I understand it, there's also a kind of algorithmic logic behind this series where you're to some degree using a kind of ideal structure, like having a kind of attenuation of the support structure to support the weight. And so there's a formal efficiency here, but of course it's also very beautiful, but it is the same beauty that we see in nature, which has its own kind of optimization. So there is a kind of ideal, kind of platonic quality to these objects that I find fascinating.
I think so too, but at the same time, you can't repeat yourself over and over in this way, if you know what I mean. It's like, in a way, what can be considered as sort of perfection is really boring in the end, because you always come up with the same result, right? So you should see this as a sort of it's an experimental work, and because you do it the first time, and it is figuring out what this algorithm can do and what it means, and what and all these things, and how it could be manufactured, and but then in the end, the tool itself, it remains a tool, right? It's like it's a computer aid that you can use to get to be informed in a smart way that is way too complex for your own brain to compute. But so I think you can't. If this was the only thing I would do, I would get crazy. Because,
it's interesting too, because it's like calling a bluff of modernism, because modernism implied that there was a kind of progressive logic that could get you to the right answer for a specific purpose. And I really love the point that you're making, that once you've found that solution, immediately you want to move on. And
I have the tendency all the time, actually, so it's it's hard. But it's funny because I heard you talk to Ron Arendt recently, and I remember we did a lecture at the V&A once, and you you talked about that little quote that somebody asked if it made sense to make another chair, right?
Yeah.
And I replied with like, hey, you don't ask a writer if he should write another book, or something like that. I don't know, but it's
or a musician, why they're writing another song when we have plenty to listen to already.
Yeah, exactly. Yeah, and well, nowadays you have a lot of algorithmically made songs, right?
Yeah.
And well, the first classical music play that was done by an algorithm, it was computed in 1 second, and I think it's 45 minutes of music that sounded like Mozart or something. It's fascinating to listen to as an experiment.
Yeah.
But then you shouldn't really use this, right? Because otherwise, if you have um, the beautiful thing with listening to music made by a musician is that you sort of communicate with the author or the creator. And if something like a piece of music is done by an algorithm, it misses all the depth and the story and the reasoning and so many layers of content that a piece of music has when it is done by a musician that you know and know his history and background, and you can relate to that and you can feel somebody's pain and all these things, and that's something an algorithm just can't replace.
I find it so interesting to hear you talking about this because, of course, you're so well known for putting robots to work in these fascinating ways. And here we have a video showing examples of this. And I guess, one way that I'm hearing you is that artificial intelligence is extremely powerful and but that if it becomes unmoored from the human scale and from human instinct and aesthetics, that it becomes totally cold and valueless because just in the same way that music that's orchestrated by a computer has no kind of poignant relationship to the human that could have made it, to the personality or to that person's history, it becomes in a way unrelatable. And I find it so interesting to hear that because you're so sophisticated in your use of artificial intelligence, but it sounds like you have a very keen limitations as well.
Yeah, well, it's maybe because we worked so much with algorithms and computers. I think we've worked on this for like 15 years, and I more and more feel like technology is more magical than the magic in the books of Harry Potter, for instance. I think technology honestly is doing things or making things possible that were like unimaginable even 5 years ago. When I was a kid, we used to dream of flying cars and hoverboards and stuff like that, right? But there was, of course, no way that we could ever make something like that in reality. But my kids now look at YouTube online or something, and they actually see, guys flying on hoverboards or rockets bound to their arms, and things like flying cars are totally possible right now. So technology has evolved so fast in the last 10 to 20 years, and it's like going exponentially fast. And I feel myself, maybe it's because we have 3 kids now, that I'm more and more trying to look for the balance, I guess, to be cautious of technology, because it is great and what you can do with it is amazing, but at the same time, it is like atomic energy, right? So you can use it as an atomic bomb, but you can also create energy with it that is low in carbon footprint or something like that, right? I mean, it has downsides, but you know what I try to say.
It's amoral, not immoral, but amoral. It has no automatic ethical association. Yeah.
But it is very important that we put it we put it on the agenda, or so, the ethical consequences of technology and things like that. I didn't feel like that 15 years ago, and this is something we are thinking about a lot.
Can I ask you a question about that to do with complexity? Because you said something earlier that struck me, which was that artificial intelligence, as in the application of the algorithm to the bone furniture, for example, can produce a form that you can't hold in your mind, or you could never create just with your own human resources. So it's a kind of assist to get you to a higher level of complexity. But I also wonder whether complexity is part of what makes technology frightening, because it allows to come to conclusions that we can't retrace. In other words, we don't quite know how we got to that conclusion, and yet the conclusion is sitting there staring us in the face. And even looking at a video like this one, which again, reiterates this image of the paper airplane, and you start to think about the building blocks of complexity and at what point it starts to escape you and become terrifying or anti-human. It just makes me think about this as maybe a dystopian reading of projects like the voxel furniture. And here we have this idea of the pixelation leading to the, more and more resolution and refinement until, So this idea that if you put together enough bits or enough pieces of information, that you start to lose control of or you become unmoored or unanchored in some sense.
Yeah, basically this is about exactly that. So it's about the implications of these technologies. And I am also amoral about this, for instance, because I think that these tables are just fabulous in the way they look. But what they mean is that this is actually based on a project done on many universities in the world, who are working on self-assembling robots. Basically robotic molecules that would assemble themselves into certain forms. And if you would be fed up with a form, you could just upload a new design to these basic building blocks, and they would deassemble themselves into a new form. Fascinating. I think it's fascinating to think about the future of that. And it has also very beautiful implications. Like, you would basically need one volume of molecular building blocks, and you can make a lot of different things. So you don't have waste, and you don't have all these other wasteful issues. But at the same time, when you zoom into reality, like if you zoom into the physical world, like I was on a boat trip to Norway, and I looked out the window at night, and you saw it was heavy weather, and you saw the waves moving past very heavily. And it was just amazing, the thought that the complexity of reality, and if you would zoom into these particles, the water particles, and you zoom into them closer, there's like an infinite world of complexity that is all interconnected with the large universe and everything. Like, sometimes you have these thoughts. But then when you zoom into to pixel, there's nothing, right? There's nothing meaningful behind it. It's just an illusion. So in this way, it is kind of like, it is science trying to mimic nature. And it's showing the iterations. Like it starts with a centimeter cube, and it goes into more higher definition, until it almost becomes a new material. And it's beautiful to look at. But I think the story behind it it's also interesting, I think.
That idea of objects being fungible, meaning they can just transform one into another, almost like money. So it just can assume a different form the way that this information does. So you can take the table apart, just build something else with the same materials. It also strikes me that has a kind of dystopian quality, because it does seem to imply alienation from our bodies. But then it also has this very empowering quality that, to me, is something you picked up in the Maker Chair project, which is really about enabling people to make things in this very, very radically distributed fashion. And I wonder if you could explain some of the ideas behind that project.
Yeah, this was about our sort of our love and hate relationship with digital fabrication and 3D printing primarily. So I think back then, when we made this work, it was at the height of the hype of 3D printing, and we always were looking at this like, what, what can you really make with these things, right? So it's usually, you know, everybody was making tiny little toys or you know, flutes or whatever, you know. It's these basically throwaway things. So we were wondering if we could make something large scale and functional with these really cheap printers that you could buy everywhere for almost like $100 or something. So we created this puzzle algorithm that allowed these affordable printers to print small parts that you could connect together to form a large object that was actually useful. And we worked together with this company called 3D Hubs that would find, if you didn't have a 3D printer yourself, it would find local manufacturers that you could ask if they would print it for you. Mm. And and we put the algorithms online, and it was downloaded, I think, 10,000 times or so. It was really successful, and we got a lot of feedback from people that actually made the chairs, and it was about the promise of digital fabrication, I guess, that you can distribute blueprints of a design all over the world, and locally people could actually manufacture it from local materials. And it also allows local manufacturing, local craft, which is, you know, a great promise, if you will. I think it is still somehow very underdeveloped.
Yes.
But it has such a beautiful promise, digital fabrication.
It also, to me, it suggests the advantage of focusing on the unit of information, because what you did was, instead of thinking about the chair as a totality, you started thinking about the structures that would produce the chair. So it's almost like you were thinking about the one bit of information, like the voxel, and then the cube that builds the table, for example, and thinking, well, what can I do in that space, that smaller space, that's then going to build out to this object, which is also, it seems to me, similar to the logic of this project of, you know, thinking about air vortices and the way that they can produce lines, or a kind of automation of drawing, maybe would be one way of putting it. And then, as we'll see in a minute when we look at the gradient furniture, again, there you're thinking about how the constituent component of the object can be the arena in which you're doing the innovation, and then the object results from that more kind of focused attention to the component as a generative unit.
Yeah. Well, one is, you know, it's called parametric design, of course. So you use a system basically that you can that you can apply to multiple purposes, and in this case, I think it's a bit different. It's also computer aided form finding, so also high in complexity, something we could never really design with your own brain. It's all random. This was done with the help of Mark J. Stock. He's a professor at the university in the USA, who works on vortexes, and they are just beautiful in complexity. And, you know, in a lot of our works is about we talk about ornament and about the sort of a conflict between efficiency and inefficiency, or sort of humanity or emotion. So in this work, I try to find the tension between ornament and function. So clients could actually choose the amount of ornament that they want in a functional bookshelf. So the lines that you see later on became the shelves of a bookshelf. But then they would be sort of destroyed by this algorithm that sort of transforms these lines into, highly ornamental ornaments. And you literally see in the work sort of the play between function and ornaments. And of course, this is a very long debate in design, right? So since Adolf Loos's famous
ornament and crime. Yes.
Yeah.
There's also an interesting relationship to time in this project, because it's like the vortex is an infinite set of possibilities, and you're just giving us one cross section or one moment also in which that form is developed. So there's a real sense of selection from a field of infinite possibilities.
Yeah, you can basically say, you can press the pause knob, the pause button, and then you get a result that is totally random or unexpected.
Exactly. Let's quickly move on to the because we're going to run out of time soon, Joris, because there's so much to talk about.
We didn't even start.
Yeah, I know, exactly. But let's move on quickly to microstructures, and then we can finish up with MX3D, the spatial printing technology that you've developed. So I have to say, Joris, this is the project, viewers, that I find hardest to understand myself. So I would be very grateful to you for an explanation of it. But again, it has to do with the idea of the component unit that used to build the overall structure, and then having an algorithmic shift of that unit across the overall space of the object. Yes.
Yeah, in a way, it is. There are similarities with the bone furniture series, where we are trying to use algorithms to create a form that is informed by analysis of tension, for instance, in a form. So if you go back to the one before this one, here you see the tension lines in a chair. The green lines are, I think they're tension, and the gray lines are compression forces, and they are transformed into the cellular structure, or they're used as an input for the cellular structure. And in this case, where the cells are dense, they become structural, and where the cells are open, they become soft and comfortable. So, like your skin, for instance, is transforming function all over your body. It is like different on the top of your head than on your back and on your soles of your feet. It's the same organ, but it has a gradient in function. And similarly, we used these principles in this design of the chair, where there's like a gradient of function flowing through the chair, while we were using one printing technique.
And also one material for the whole.
And one material, yeah. So with one material, you could make it soft either or structural. Right. Here you see the printer that we used to create the gradient aluminium chair. This is how it comes out of the printer. This is a machine that's usually used to make medical implants. And we were able to transform the machine to print in aluminium, which was never done on that machine.
So you're directly printing the aluminum here rather than printing something in which you're going to cast the aluminum. It's a direct print of metal.
Yeah. Yeah, and it's fascinating to see what you can do with these algorithms. So the chair is transparent from three sides, or from the top, from both sides. You can look straight through the chair, while it is a three-dimensional structure. And so the chair here is solid where we need its strength and stability, and it becomes more lightweight and open where you want to reduce the weight of the chair.
It's fascinating too, because it's almost flip of the heat wave radiator, where now structure has become the ornament. The logic of it has become this very kind of decorative thing of the coming and going of the form.
Yeah.
Creates pattern, I suppose is what I'm saying. Yeah. Mm-hmm.
Yeah, these are sketches, really sketches.
Mm-hmm.
But all these chairs have similar concepts. And this chair was based on long cells that would morph into different functions along their height.
Mm-hmm. How do you select the materials in which you're going to make these objects, like the copper, for example, in this case?
Well, this technique of growing metal on a plastic, basically, is first done in copper. So copper is only highly corrosive, which is not easy to solve. So usually it is used with an end layer of nickel. But when I saw the chair done in copper, it was just too beautiful to then create a nickel layer.
So this was going to be an intermediary step and was going to get
Yeah,
covered
which
up.
we
We had to stop it there. Fascinating. Well, if you don't mind, I'm just going to,
go ahead.
beautiful object, but I'm going to move us on to MX3D, which is our last big topic. And it is a big topic because I have to say, Joris, if you had invented nothing else, this would already be enough to have made a figure of historical significance in design history. So again, if you could just explain the technology, but then also the ideas behind it and its implications.
Oh, yeah. Yeah, the sound can go. So this was a research project which also started with our love and hate relationship with 3D printing, and we wanted to make a printer that allowed us to print large scale because all the printers that we were able to buy only allowed us to print in these small bounding boxes. So we bought a second-hand robot arm and wrote software to control it. Usually robots are pretty stupid machines, actually. They're really old and are always used for a single purpose, so a single movement, for instance. They're really good at repetitive movements. But right now with new software, you can actually make the robots do these infinitely complex movements. This is a robot printing a resin that is hardening so fast that you can draw in mid-air, and we can in real time add coloring to it. So you see the light blue color going into a darker blue. That's done in real time with syringes injecting color to this resin. And this allowed us to draw in mid-air, basically, also horizontally from the wall, which was really crazy to look at. But then the material was still a bit too weak, and we couldn't really use it to create large-scale functional objects. So we thought, what if we connect a welding machine to a robot arm? And this is the welding machine printing in stainless steel. And this was never done before, so this was totally experimental, and everybody was telling us this was impossible. And this started with us doing these little blobs that you see on the metal plate. We had to work for 2 weeks and nothing happened, and then we sort of tweaked and we literally tried every way we could use those welding machines. And eventually it worked. So after this video, we were really literally sitting on our studio table like, whoa, if this is possible, we can basically do anything. So this started with doing these sculptural benches for Friedman Benda, our gallery in New York. This is another version of that in our exhibition at the Groningen Museum. This shows us printing surfaces. On the left side you see dots, and on the right side you see continuous lines. With dots we can create the most crazy forms you can imagine. in any inclination. It's super promising. We can print any weldable metal. So this is the first piece we did in bronze. We just finished a new piece in bronze, by the way. We're just trying to push the limits of this technology, and we created a new company around this called MX3D, and they are basically working on industrial applications for this tool. And our poster project that helped us start the company basically is this bridge. This was the first animation that showed the dream that we had. So robots would start from one side of the water, started printing their own support structure until the bridge was finished, and then you could walk over the water. Eventually, we talked to the city of Amsterdam. We are from Amsterdam, so it's a city of canals, so it made a lot of sense to do a bridge and to get the government of the people from the city interested in doing a bridge. So this is the oldest canal in Amsterdam where the bridge is going to be placed. Here you see again us using algorithms as tools to inform us with what would be the ideal shape. Eventually, we had to move to a totally different approach because the construction world is way not so far as the design world is. So the people that had to prove its safety wanted to go in a different direction. And this is what you see here. So again, the red lines are compression forces and the blue lines are tension forces, and that was the input that we used to create the design. The heads of the bridge are not directly opposite to each other, so it creates this from top view it has this S-curve, and that creates an interesting sort of stress that is not so obvious. This is a scan from the canal that we had to use. The nice thing with digital fabrication too is that you can adapt it for any place. So if we would have to do the same bridge for a canal in Venice, for instance, it is very easily adapted. We basically have to scan the next canal and we can adapt a similar principle to another situation.
Mm. So that's parametric design in practice again.
Yeah, and the bridge goes even further because it's also hooked up with a lot of sensors. So real time, this is an old design, by the way. So you can move forward with the, this is a sketching. Mm-hmm. That's again but the bridge is hooked up with all kinds of sensors that measures the health of the bridge and the people walking over the bridge, so it can monitor crowds. So it helps the city also to understand how busy certain places in the city are and stuff. Mm. This is sort of a sculptural work that we printed to see what the bridge would look like and how to print this. You can move on to the next. This also.
And there's a bridge itself.
Yeah, that's the first rendering of the bridge. And I think in these last videos you see how it is made, and this is the top view. It's a pity that you don't see the actual bridge deck structure anymore because of all kinds of regulations. We had to put a steel deck over it because if women had to walk over it with heels, they could not get stuck into holes, and horses needed to walk over. There's all kinds of regulations. This is us mimicking hooligans jumping on the bridge for safety. Mm-hmm. Because you cannot, it is not standardized, this material. We had to have pretty rigorous safety procedures, which is all done together with Arab, which is a really famous international construction company that helped us with the calculations and stuff. Mm. This was in Eindhoven during the Dutch Design Week where it also won the innovation and the public awards. So that was nice. And now I think before the summer, it eventually, after so many years, is going to be placed in Amsterdam, because the canals had to be redone. They were really old, and the city was sort of slowly sinking. So we had to wait a long time for the city to actually finish them. But yeah.
It's such a heroic project, and it's fantastic that it's finally going to be put in place. But, you know, cathedrals took generations to make, yes.
We should make more cathedrals. It is very important. Yeah.
I think that's a commission that you definitely should get. We'll just finish with this last video, which shows the exhibition that many people may have seen at the Cooper Hewitt in New York, and it was also the Groningen at the High. And where else did it go, Joris?
Houston. And
of course, Houston, yeah. Yes, and in fact, we have Cindy Strauss with us on Friday as our guest, so she was the curator of it there. Yeah, and I think now we have gone a little over time, but of course there's been so much to cover, so I thank you for going through it so quickly. It's just amazing. And the fact that you've only just turned 40 this year is quite astonishing, I must say, given all that you've done. But I would like to take a couple of questions from the audience, if we could. And first, let's go to Michelle Jaffe, my friend, who has a question for you, or a comment. Michelle, are you there with us?
Yes, I am.
Hey, Michelle, how are you?
Hey, how are you? This has been wonderful. Thank you.
Thanks for tuning in. What's your question?
Oh God, did I raise my hand? I've been making comments along the way. I have all sorts of questions actually, so cut me off whenever you need to. The S curve in that last in the bridge, did that give some sort of structural support? In the way arches did in the past in Gothic cathedrals. Did that compounding of the curve add something to the structural?
No, it was more of a complication.
Okay.
But it is a nice complication, because it shows how adaptive these generative design tools are. If it was just a straight bridge, it would probably result in a very logical arc. But if you look closely to the stress lines in the bridge, the arc already touches the bridge deck before it is on the street. So the stress lines also go over the bridge deck. It's a complicated story, but I think it shows how adaptive generative design is. Right.
And so the body of the bone work, I mean, obviously in a way is sort of informs all of this work, doesn't it? I mean, it's huge.
Yeah, it's yeah.
Another question on that. When I first saw that work, I guess when it was shown probably at Friedman Menda years ago, I thought that's coming from sprues, from a regular small form. What am I trying to say? From a regular mold that you use for jewelry, you have to, make the pathway or the canal for the metal to shoot into the casting, right? And that's the way I originally read it. But hearing you today, I think maybe you came to that from a completely different perspective. Is that right?
Yeah. Well, yeah. I didn't know how to make jewelry back then.
Right.
So I don't know, but this appeared to us the only way we were able to make this, by 3D printing ceramics.
And as one form.
Yes.
Right.
Yeah.
Right. Right.
I like the fact, Joris, that not knowing something doesn't usually stop you from going on and doing
it. Actually, not knowing sometimes is the best thing, right? Because you come up with some other thing, and yeah. Very cool. Anyway, the work is stunning. I mean, it's really gorgeous.
Thanks.
So.
Let's get a question from Peter Fleming. Peter, are you out there?
I am.
Hey, good to see you.
Hey, Glenn. Yes, indeed. What a fascinating presentation here. Joris, you've managed to liberate us from what many people think of as a kind of tyranny of digital design in some way. And your earlier comment about what constitutes the optimal approach, I think as you've gone through all of your presentation today, you've sort of described how how you have personally chosen a way to go through and find an optimal approach that's more interesting than what would be expected. But I wonder, does it have implications for mass customization on some level? It seems that it's a very bespoke project that you're involved in, but some of the projects like the bone chair or the second iteration of that has other possibilities. Is it a strictly one-off lab situation that you're running, I guess?
Well, we tend to like, I like to experiment. I like to go from the one experiment to the other, and we like to create the most expressive works that we can make to communicate to an audience as large as possible, to inspire as many people as possible. That's what we are good at. Other people are good at translating those ideas into industrialization, for instance. We've set up for the metal printer, for instance, we had to set up a company, and this company is printing moon landers, for instance, or robotic arms and things like that have nothing to do anymore with my experimenting with sculptural form. And the similar thing with the algorithms for the bone furniture. I know the former CEO of Autodesk, for instance, the software company from Silicon Valley, who also approached us for like, hey, how did you do that? And like many years ago, and now they have it in their software package. And we also work with their engineering team on new ways to use that type of software, also for the bridge and things. So we have implications for mass customizations in a larger audience, but in not such a direct way as you would think, I guess.
Great. So let's just take one last question from Eric Arsofsky, who has some questions about materials. Eric, do you want to go ahead and ask Joris about this range of topics about biomaterials and so on?
Sure.
Hey.
Hi, how's it going, everyone? I've really enjoyed the talk so far. I've just noticed recent innovations with new biomaterials coming up, and there's very exciting companies in Europe, all through the Middle East and US, who are printing with certain earthen materials to sort of construct houses from the ground up, layer by layer. And even featured in the show, I believe, the Cooper Hewitt, there was an example of algae 3D printing. And I'm just wondering what you might think is maybe the next most exciting material to work with.
Yeah, so we are at the moment very much working on projects with biocomposites, for instance, and wood and timber. I'm a new believer in a very old material like timber that can be beneficial to us in many, many different ways. This is something that is pretty hot now in the architecture world, of course. I don't know if you've noticed, but we should plant as many trees as we can, and we should try to put as much carbon as we can into the most beautiful objects that you can imagine, so we store it for the most amount of time. And that's something we should all work on really hard, to make beautiful things that you don't want to throw away. And if they should be thrown away, then they should be compostable. That's the thinking. Any biomaterial makes a lot of sense, in my opinion. I know those people they were printing with algae, by the way. They're friends, and they're like, I think it's brilliant.
And you're actually working on some timber architecture for the, just to bring us full circle, for this kind of land that you're on, this commune that you're building.
It's still very in an early phase, but yeah, we're studying on how we could use digital fabrication and timber architecture, and how to combine them in a smart way that is also that we can also use in a in a larger volume than we usually work in.
Okay. Well, Joris, I think we're going to have to leave it there, unfortunately. There's so much more we could talk about, but I think people need to go have lunch here in America. Maybe you need to have dinner. Patricia Taylor just said in the chat box that throughout the presentation she kept thinking Leonardo da Vinci, and I know it's not the first time the comparison has been made but certainly like Leonardo, I have a feeling we're going to be catching up to your ideas for a very, very long time, and it's been an incredible opportunity to talk to you and sort of dive into some of them. So thanks so much for joining us.
Great, thank you.